everybody, welcome back to the hidden secrets of valve lash. This video started out as being about some secrets to valve lash and the benefits, pros and cons, and I've had a lot of questions. First of all, thank you for watching the video. I hope you all learned something from it, but I'm going to answer some questions that we had come up about it. So here we go, and I hope this clarifies some things for some of you. One of the questions was, does this apply to all camshafts? Yes, and I said that in the video. This applies to every 4-cycle engine that's ever been made. And when I say this applies, what I'm talking about is the method to get to the point of checking valve lash. That is, rotate the engine in the direction of rotation until the exhaust valve starts to open. And that's when you'll set the lash on the intake valve of that same cylinder. Then continue rotating the engine, direction of rotation, until the intake valve opens and starts to close. That's when you'll set the lash on the exhaust valve. Now, go by your cam recommendation. What I was encouraging you to do was don't be afraid to move your lash around and try things. So the question was then posed, well, how much is safe? Because if you remember, I made a comment that on one of my engines I did on the dyno, I couldn't get it to run the way I wanted it to run. It ran great, but not the way I wanted it to. And that I had loosened the lash up a ton and wound up picking up 38 horsepower. So what is safe? And if I believe I said also that, but with the cam and valve train I had in the engine, I couldn't leave it that way. What is safe? Okay, this is, I think, a really safe number to tell you. I would never exceed 30 thousandths of an inch. Never. You can if you want to. I just would never do it. I'm not ever going to send the engine out of my shop with 30 thousandths of lash in it. Okay? You can do it for a very short period of time, but let me tell you what's going to happen. Just like in the first video, I showed you that you are crashing that lifter into the push rod rocker arm valve itself. I mean, guys, you don't realize the pressure that you're applying. Now, I'm talking about racing things here, okay? Because in some of these stock vehicles, some of these spring pressures are not even 70 pounds. I mean, I've literally have pushed some of these little 4-cylinder valve springs open with my hand. The shock of a very loose lash on something like that is not near as much as a spring where I'm running 400 pounds on the seat and 950 pounds open pressure. We're talking about 1,000 pounds or close to it that all of a sudden you're slamming into like a semi truck hitting a brick wall. You're going to break stuff. The roller wheel or the flat tap, we don't run that much spring on a flat tappet motor, but you get the idea. You're crashing components together. So if you want to try something on the dyno, the engine, maybe you're trying to pick up stuff, you're trying to learn, okay, especially in a learning environment, yeah, open it up to about 30 thousandths, see what happens. And if you get some gains from it, then reevaluate the camshaft you have in the car. Now, I don't care what cam you put in it. A lot of times you're always going to, you're not always, but no matter what cam you have in it, if you speed up the valve action, you're going to get some gains, okay? That's just common. But to gain almost 30 horsepower, you could do a cam change and fix that loose lash, okay? So again, I told you, I think I backed the lash off to like 28 thousandths. I picked up 38 horsepower. And then the question was posed to me, so what did I do? And because I told you in the video, you know, I didn't want to send it out like that. Number one, it's noisy. And number two, this was an endurance engine. When I say endurance engine, my engines will run for 2 hours at 8,000 plus RPM. I'm not going to have 30 thousandths of lash in my valve train beating the heck out of them like that. Now, other people may do it, and that's fine, but I'm just not going to do it. So what did I do? What I did was I put a degree wheel on the front of the crank, and I measured my valve timing events at that lash. And from that information, I went back to my drawing board and I changed my camshaft. And I'll tell you how I did it. The lift on that cam was 738, I believe, with the lash. Okay, so it was like almost 770 thousandths roughly. We turned the motor 8,700, 8,800 sometimes. So what I done, and I had a 165 rocker Jessel shaft system on it. So I changed my ratio to a 1/8. I went to a 1/8, or maybe it was a 1/85, and I went to what's called a the lobe lift on the cam itself was lower. So I accomplished the same total lifted valve with a higher rocker arm ratio, and I was still able to run my tighter lash. You say, well, how does that work? Well, if you remember, the lobe lift times the rocker ratio is your lifted valve minus the lash you have in it. And the cam that was in there, the lobe lift was fairly high. It was like in the mid 400s on the lobe lift. Sorry, I'm tongue-tied. So I got a camshaft with much less lobe lift, same duration, and I put a much higher rocker arm ratio on it, accomplished the same lift, and my horsepower came back. Now, here's the question. Did I try loosening the lash on that cam setup? And the answer is yes, I did, because I try everything imaginable. And I didn't get the same results. I might have picked up 5 to 7 horsepower loosening the lash. But again, guys, we're not trying to build hand grenades, okay? By gaining another 30 horsepower with my lobe lift and rocker arm ratio and being able to run a tighter lash, what I did was I ensured that engine could make it 2 hours at that RPM range and not have lifter failure or breaking rocker arms or slamming and bending push rods. There's a thing called push rod pole vault, and basically it's when you're trying to overcome such cylinder pressure and valve spring pressure that the whole push rod rocker arm just distorts out of shape because it's overcoming that pressure. And then all of a sudden it snaps back, and when it snaps back, that's when you can slam valves into the seat, you can break push rods, all the, that kind of thing. So I was able to keep my lash tight, accomplished almost exactly 38 horsepower, came out to like 33, 34, and I was fine with that. My lash was tight again. I'm happy. It's going to last. Again, before you finish first, you must first finish. So it's all about building a repeatable engine, a very, very strong as I can make it engine that will endure the torture that driver is going to put it through for 2 hours straight and sometimes longer. Now, concerning valve growth, we had a question was, well, does this matter if it's aluminum head or steel head? And guys, going back to the premise of the first video was to show you when, how to set valve lash, meaning I showed you the procedure. Exhaust valve starts to open, set the intake. Intake starts to close, set the exhaust. That process is for every 4-cycle engine, okay? But the only difference between iron heads and steel heads is the growth you get from being hot and cold. Okay, in my experience, traditionally speaking, I will see aluminum valve lash on aluminum head grow around 6. Sometimes a little more, sometimes a little less. Depends on how hot you get it, okay? Remember that. So if you cook the thing 250 degrees and it grows 10 thousandths, don't message me and go, My lash grew to 10 thousandths. Well, yeah, because you're 100 degrees too hot. Anyway, you get my point. Whereas steel will not grow that much. So pretty much, if I need my valve lash on an aluminum head set to, let's just say, just for easy of math, let's just say 10 thousandths lash, I can expect it to grow 6 thousandths. That means my cold lash setting will be 4. When it gets hot, it's going to be dead on 10. Now, I've had engines, especially some of the larger big blocks and blower motors, where the valves barely close cold because the lash is 0. And when they get up to temperature, they're at 20-some thousandths lash. So you have to understand what you're working on. Remember, this is a racing engine. Okay, so you're going to have those growths like that. With the steel head, I've actually had some setups where I've actually set the steel-headed valve lash 2 thousandths larger than what the lash should be. So if the lash should be 10, I've set them at 12, and when it got hot, it closed up to 10. All right, so you'll know these things if you'll just check them hot and cold. And when I say cold, I mean completely cold. You can't run it and then 2 hours later go check it because it's still got heat in it. Has to be room temperature cold. That way you know how much movement you have in your valve train. Rocker arm ratio. Somebody asked, did rocker arm ratio have an effect on my valve lash? The answer is absolutely not. It does not. It has an effect on your duration. It has an effect on the lifted valve. It definitely opens the valve much faster. Okay, the higher the rocker arm ratio, the faster you're opening the valve. And somebody asked me or made a comment that, man, if your thousandths of an inch is changing up to 3 degrees of duration, you must be having a hellfire of a cam lobe. And I responded, yes, we do. I mean, guys, we have cam lobes and rocker arm ratios that literally open the valve like this. Okay? We're talking, I'll get into this at some point, but when you look at cylinder head flow, put all the port stuff aside. What is in the way? The valve. The valve is what's blocking my flow. I want that valve out of my way so that as that piston is traveling downward, I can take maximum use of the port of my cylinder head. If I'm still fighting the valve, if the valve is still barely cracked off the seat, that valve is going to cause my flow to be distributed, and it's just going to disturb everything, all right? Now, I'm not saying we don't make good flow numbers with valves in place. We do. But if that valve wasn't there, imagine. I'm talking on good stuff now, not just some junky heads. All right, so again, the most lash I would run on my cam stuff is 30, and that wouldn't be for long periods of time. Don't be afraid to try stuff. Just don't get crazy with it. You don't want to break your components. Talked about the growth between aluminum and steel. Oh, somebody says, well, okay, how does that work with the aluminum head? So what happens is, and I'll make sure you can see this. This is a steel head, but pretend it's aluminum. What happened is, the reason why aluminum, you're going to gain 6 thousandths lash here when it gets hot is because, remember, it grows in all directions. North, south, east, and west. So as it grows south, right there, look, what is the seat pressed into? As it grows south, the head swells and it pushes the seat, which makes the valve tip go away from the rocker arm, okay? So steel heads have a different growth factor, but that's how that works. Now, let me make sure I didn't miss anything. Nope, looks like I got it all. Now, I want to show you how to go set some valve lash here. We're going to do Hydraulic representation. I want to show you about the stud girdle we have on the one engine out in the shop, because on most stuff I do, it's a Jessel or T&D rocker shaft system. But check this out. I want to show you one of the typical hydraulic lifters, a typical solid lifter, a solid lifter with an oiler in it, and why that's important. And I want to show you a neat trick with your valve adjustment nut. This will help you. And here's the reason. Let's talk about the hydraulic. When you adjust a typical hydraulic lifter, most manufacturers will say they want the plunger, that's the part the push rod sits in. I'm going to show you a demonstration here in just a minute. They want that plunger depressed 20 to 60 thousandths of an inch, okay? How do you know it's depressed 20 or 60 thousandths of an inch? I'm going to show you a really neat trick. Stay tuned. All right, guys, so we talked about hydraulics. Let me show you something. Now, here is a typical hydraulic lifter, and this is a push rod. By the way, I use Trend push rods. This is a 135 wall. Anyway, we'll get into that later too. I want you to see something. Right there is called the plunger. That's this component right there. And what we're doing when we tighten up the valve lash is we're pushing that down. Can you see that push rod going in? Okay, and most manufacturers want 20 to 60 thousandths of that cup right there depressed. Using the method I gave you, exhaust valve starts to open, adjust the intake. You would go to the intake and adjust that nut 20 to 60 thousandths depressed. Now, how do you know how much you're actually doing? I'm going to show you a really neat little trick. This is called a poly lock, okay? And this poly lock is used on most high performance applications when you're using a stud mounted rocker arm. That poly lock is used to tighten down your rocker arm and to set the lash on your rocker arms. The Allen head is so that once you make your adjustment, you hold this steady and tighten that set screw down tight so that the vibrations and whatnot won't let it back off. So it will be exactly where you set it. How do you know how much is going on here? Well, watch. I'm going to show you a trick. This bolt is the same thread as a rocker arm stud. So let me get this measured up here. All right, everybody see that? It is 4.401 inches, okay? Now I've marked this because here's what I want to show you. I'm going to rotate that nut one revolution, and let's see what one revolution does. So here we go. I'm going to rotate it one revolution. This would be like one turn on your rocker arm. And look what it done. Now it's at 4.352. So if you do the math, 400 minus 350, what's the difference? 50 thousandths of an inch. So a poly lock, one turn of rotation will depress that plunger in your hydraulic lifter 50 thousandths of an inch. That hopefully will answer a whole lot of questions for some of you. And now next, here we have a typical solid lifter. And I want to tell you something, this is something I recommend. So this is just some good info. Here's a solid lifter. I want you to watch what I'm going to show you. This is, I think, a Morel lifter. They usually come with very highly polished bodies. This is just some stuff I had laying around. I always purchase them with something special. Look right here. Let's see, I've got it in magnifying glass. Oh, there it is. Everybody see that black dot? Right there, right in the middle of the lifter body. Everybody see that? I have to be in front of the camera, guys, sorry, but it's right there, the black dot. That dot is a 12 thousandths hole that was put there on purpose. That hole goes through the center of the lifter body to the plunger. All right. Now, the purpose of that is the oil that travels around the body of the lifter, being this is solid, the oil can go in here, but it's not doing anything. The oil pressure from the engine does not make this cup rise or fall or any of that. It just simply lubricates the lifter body. So what we've done is that hole, instead of working a hydraulic mechanism, now the hole goes in the lifter, and guess where it comes out? Right out of that 12 thousandths hole right there. And what that does for you is lubricate your cam lobe on a flat tappet cam to help with longevity. Especially if it's a very aggressive cam. It keeps the wear down. It keeps the heat down. It keeps metal shavings out of your oil. Plus the oil goes in the plunger and up the rocker, or up the push rod. As you can see, you got a hole. Okay, goes to your rocker arm, lubes the cup to rocker arm, goes in the rocker arm body, and lubricates the bearings and the pivot ball and all that. So really great to know those things. I highly recommend these. If you ever go solid flat tappet, get one with a 12 thousandths hole in it. Okay. Now let's go to the shop and set some valves. Okay folks, we're back. Now here is the poly lock I was describing to you. Now this is a long one because this particular engine does not have a shaft system. It has a traditional style rocker arm. So the poly lock is long because we are running a stud girdle. Okay, so that goes inside there like so, and what that does is evenly distribute across the entire valve train where the spring pressure is so much. You don't want your rocker shaft moving like that due to the spring load. So it ties all them together and gives a lot more strength. Now, we're going to act as if we're setting our hydraulic valves, okay? Hydraulic valves. First of all, when you got a rocker arm like this, I want you to pay attention here. There's a flat in there. So I'm going to rotate this. You see how that right there, that's got a radius bottom. Make sure that goes to the bottom. And there's your flat. And that flat is where this sets, right on top of there, okay? So, I'm now going to show you how to get to zero lash on your hydraulic camshaft. So let me run this down. And we'll set the intake first. So I'm going to bump the engine around in the direction of rotation in case you're using a wrench. If you're using a wrench, don't go cranking the engine backwards. Always go in the direction of rotation, okay? I'm going to bump it around. All right, here we go. We're going to watch the exhaust valve. Start to open right there. Everybody see that? All right. I'm now on the place I want to be on the cam lobe to set my lash for hydraulic. So here's how I find zero lash. What I do, and I'm going to take this off again. What I do to be sure is some guys will grab their push rod and twist it and this, that, and the other. I don't like doing that. This is what I'm doing. I want to take my push rod. I'm going to go up and down. By the way, that black in there for all of you is ARP assembly lube. This is what I'm doing, okay? Remember, zero lash is supposed to be where there's no play between the rocker arm, push rod, and lifter. It's not about tension. That's why I'm not using the twist method. What I'm going to do now, without depressing the plunger, remember how easy that was to push down, I'm going to screw this down. And I'm going to take my push rod and go up and down in my push rod until I get all that out. Okay, and right there, my push rod can no longer go up and down anymore, okay? The rocker arm will move side to side, so don't let that worry you. It's the up and down that you're concerned with. And then you would simply decide on how much preload you want to put. I've already told you that if we go 180 degrees around, or excuse me, 360 degrees around, how much is that? That's 50 thousandths. How much preload does most lifters require? 20 to 60 thousandths. That means that half a round is 25. Okay? You can divide 25. That's about 12 to 13 going a quarter round. All right? So that means if I go half a round, there's 25. And right here, add another 12. So that would be what, 37? No, 10, 35. Yeah, 37,000. That'd be 37 preload. All right? All the way right here, that'd be 50. So you can figure out how you want to set it. I'm not going to tell you how to do it. But I can tell you that one complete round is 50 thousandths depression on that plunger on a hydraulic lifter. The next step you'll do is rotate the engine through until the intake valve opens all the way and starts to close. Set your exhaust valve, get your up and down motion on the push rod out, and then make your adjustment. I like to use that method because I can be gentle with it. I'm not going to over tighten my lifter. I'm not worried about spinning it. I don't care about any of that. I want that push rod touching the lifter and the push rod touching the rock arm. That is zero lash. That's what zero means. If you go twisting it any tighter, you're past zero lash. Okay? That's why I use it. Now, don't go sending me no crazy comments, because anyways, zero lash, that's what we're after. Once you make zero lash, then again, you now know how much one of these turns. So half a turn is 25. Quarter turn is 12 and a half. Full turn is 50. You need between 20 and 60 depression on the hydraulic lifter. And folks, that's it. Now, let's move on to solid flat tappet or solid roller. Doesn't matter. With a stud girdle. Here we go. Okay, we're back now, and this time we're going to adjust the solid lifter of any kind, roller, flat tappet, it does not matter, with a stud girdle. I want to show you something. Watch right here. I'm used to working left-handed, y'all. Here we go. Watch right here. Watch this stud. Everybody see that stud move? Do not adjust your solid lifters with a stud girdle unless it's put on. Why? Because if you adjust these valves without the stud girdle on, when you do install the stud girdle, your valve adjustment will be out the window. Okay, so install your stud girdle and just barely snug them up so that they're making full, complete contact. And all you want is just a little bit of snugness. See, that's not even tight. Now it's just barely getting snug, and that's all I want. Okay, that's all the tightness I need. That's all I need to loosen it, is just that right there. Just a little bit of looseness, okay? That way, when you're done adjusting the valves on your solid cam, roller or flat tappet, they will be where you put them. From here on out, you use the same method I showed you. When the exhaust starts to open, set the intake. Intake starts to close, set the exhaust. And remember, you're going to get 6 thousandths growth on an aluminum head. And check your own. Feel free to check your own. Check them hot, check them cold. You'll know how much growth you're actually having on your engine, okay? That wraps it up for Lash right now, fellas. We tried to answer some of your questions, and I tried to show you some more things. The main thing is be consistent, check it often, okay? Try some stuff. You know, plus or minus 5 and 10 thousandths here and there. Try to stay less than 30 thousandths lash. Remember, I build engines for people, for customers. I'm not going to adjust the lash recklessly just to get a couple horsepower, okay? I need their engine to survive. So in the case where I put a cam in, it was really not the right one, evidently. So what I did was shrink my lobe lift, went to a higher rocker arm ratio. I got the horsepower back, and I was able to tighten my lash back, and now the engine is safe. I don't worry about hammering on the valve train and all that. Hope you learned something. Try what I'm saying, okay? Try it and do it exactly like I'm saying. If you're not sure, because if you do this backwards, you're going to screw up. If you're not sure, watch the video again. Let me drop a name. If you enjoy vintage engines, getting rebuilt and dyno tested with different cams and stuff like that, and if you love the detail, these people I'm about to name, they got good videos, and they show some old stuff that I love watching, old Pontiacs and Fords and Chevys, and they build them up to, you know, 450 to 550 horse, and sometimes a lot more. But just a great in-depth channel, and that is Gold's Garage, Alan Gold. If you just want to see some good old-fashioned vintage stuff, I love watching his channel. So go to his channel and check him out. I'm sure we'll have more channels that we like. I actually do. But I talked to Alan before through messaging, and also I talk a lot with David Vizard. Want to wish him a get well, and we're going to be doing some stuff very soon. He wants to do a collaboration, so we're working on some stuff with him. But I hope you guys learned something. Have a great rest of your week.